students, today we are going to study evidences for structure of glucose under biomolecules. But before that, let's see the preparation of glucose. So, preparation of glucose. We will prepare glucose from sucrose, C12H22O11. Sucrose on undergoing hydrolysis gives C6H12O6 glucose plus C6H12O6 fructose. So, the preparation of glucose is like we prepare glucose from sucrose C12H22O11. When sucrose undergoes hydrolysis, it gives glucose as well as fructose. Now, let's move on to the evidence of structure of glucose. But before that, let us first see the structure of glucose. So, the structure of glucose is like this. CHO, CHOH whole 4, CH2OH. So, what all we have to prove? We have to prove that glucose have an aldehyde group at the first carbon, a primary alcoholic group at the sixth carbon, and 4 secondary alcoholic group. And overall, it has 6 carbon atom and it has a straight chain. So, this is the structure of glucose, and we are going to prove all of the evidence that we are going to give all of the evidences for the structure of glucose. So, let's start. There are total 6 evidences, or you can say proofs, for the structure of glucose. The first one is hydrogen iodide. Reaction with hydrogen iodide in the presence of red phosphorus accompanied by prolonged heating. So, the first one is reaction with hydrogen iodide in the presence of red phosphorus accompanied by prolonged heating. So, when CHO, CHOH whole 4, CH2OH, that is our glucose, reacts with hydrogen iodide in the presence of red phosphorus accompanied by prolonged heating, then N-hexane is formed. So, whenever glucose reacts with hydrogen iodide in the presence of red phosphorus accompanied by prolonged heating, then N-hexane is formed. This reaction proves that structure of glucose is a straight chain having 6 carbon atom. So, this is the evidence for the structure of. This is the first evidence when hydrogen iodide reaction of glucose with hydrogen iodide in the presence of red phosphorus accompanied by prolonged heating and hexane is formed. This proves that structure of glucose is a straight chain having 6 carbon atom. Moving on to our second evidence. So, our second evidence is reaction of glucose with hydroxylamine or cyanohydrin. When glucose reacts with hydroxylamine, structure of hydroxylamine is NH2OH and cyanohydrin is HCN. So, when glucose reacts with hydroxylamine NH2OH D-glucose oxime is formed. This is the structure. This is the structure of D-glucose oxime. Now, what does this reaction prove? This reaction proves that the structure of glucose contains a carbonyl compound. It is not specified that whether it is containing aldehyde group or ketone group. It is just proving that the structure of glucose contains a carbonyl compound, and that is our aldehyde. But it is not specified here. It just says that it is presence of a carbonyl compound. So let's write. It proves that structure of glucose contains a carbonyl compound. Structure of glucose contains a carbonyl compound. So it can also be proven by the reaction of cyanohydrin. Let us write it also. When it reacts with cyanohydrin HCl, the presence of OH minus COH, Cl, CHOH4, CH2OH, that is glucose cyanohydrin is formed. This also proves that the structure of glucose contains a carbonyl compound. So either with the hydroxylamine or with cyanohydrin, glucose reacts, and with the cyanohydrin, glucose cyanohydrin is formed, and with hydroxylamine, D-glucose oxime is formed. And both of these reactions prove that the structure of glucose contains a carbonyl compound. Now, the third one is reacting with a mild oxidizing agent. Third one is reaction with mild oxidizing agent. So CHO, CHOH whole power 4 means 4 bracket 4, CH2OH plus oxidation with oxygen, presence of bromine water. So here our mild oxidizing agent is bromine water. So when glucose reacts with bromine water, that is a mild oxidizing agent, any mild oxidizing agent, here we are taking bromine water, then gluconic acid is formed. COH, CHOH over 4, CH2OH, gluconic acid is formed, and this proves that the structure of glucose contains an aldehyde group at the first carbon atom. Proves that glucose structure contains an aldehyde group at first carbon. So the first carbon there is an aldehyde group. This is proved by reaction of bromine water with glucose. That is, any mild oxidizing agent when reacts with glucose, gluconic acid is formed, and this proves that there is a presence of an aldehyde group at the first carbon atom. Then moving on to our fourth evidence. Our fourth evidence is a strong oxidizing agent. That is, reaction of glucose with a strong oxidizing agent. Here we will take concentrated nitric acid. Reaction with strong oxidizing agent. CHO, CHOH, CH2OH, glucose, and reacting with strong oxidizing agent. Such structure is obtained. So, whenever glucose reacts with concentrated nitric acid, we obtain a structure like this. And since here we can see presence of COOH group at the 6th carbon, we say that this reaction proves that there is a presence of a primary alcoholic group at the 6th carbon. So, this reaction proves there is a presence of primary alcoholic group at 6th carbon position. So, reaction with strong oxidizing agent, whenever glucose reacts with strong oxidizing agent, such a structure is obtained, and this reaction proves that there is a presence of a primary alcoholic group at the 6th carbon position. Since we can see COOH, and whenever alcohol gets converted directly into acid, this proves that there is a strong oxidizing agent. And this strong oxidizing agent, since this glucose has reacted with strong oxidizing agent and we have obtained a COOH group, this means that there is a presence of a primary alcoholic group. Let's move on to our 5th evidence. That is reaction with acid anhydride. First one is reaction with acid anhydride. Acid anhydride. So whenever glucose reacts with acid anhydride, so pentacetate is formed. So whenever glucose reacts with acid anhydride, pentacetate is formed. This reaction proves that there is a presence of 5 alcoholic group in the structure of glucose. However, it is not specified whether it is primary alcoholic group or secondary alcoholic group. So when glucose reacts with acid anhydride, then pentacetate is formed, and this reaction proves that there is a presence of 5 alcoholic groups in the structure of glucose. So this reaction, okay, I'm ready for this reaction proves that there is presence of 5 alcoholic group in the structure of glucose. So this was the 5th evidence, which shows that there is presence of 5 alcoholic group in the structure of glucose. Now moving on to the last evidence, that is reaction with phenylhydrazine. The 6th and last evidence, reaction with phenylhydrazine. Structure of phenylhydrazine is C6H5NH2. Let's react it with glucose. CHO, CHOH, CH2OH. This is our glucose. Glucose on reacting with phenylhydrazine C6H5NH NH2 minus H2O. We obtain glucose phenylhydrazone. So whenever glucose reacts with phenylhydrazine, we obtain glucose phenylhydrazone. So, sixth evidence is that whenever glucose reacts with phenylhydrazine, we obtain glucose phenylhydrazone. And this reaction proves that there is one primary alcoholic group and 4 secondary alcoholic groups. Okay. So, on reacting glucose with phenylhydrazine, we obtain glucose phenylhydrazone, which proves that there is presence of one primary alcoholic group and 4 secondary alcoholic group. This reaction proves that the structure of glucose contains one primary alcoholic group and 4 secondary alcoholic group. So this was the sixth and last evidence for the structure of glucose, that is reaction of glucose with phenylhydrazine, which when reacts with it, glucose phenylhydrazone is formed, and this reaction proves that the structure of glucose contains one primary alcoholic group and 4 secondary alcoholic group. Now, one condition that we can see in this reaction is that if phenylhydrazine is present in excess. So, let us see that reaction. If in case phenylhydrazine is present in excess, what will be formed? So, if phenylhydrazine is present in excess, if our phenylhydrazine is present in excess, then a structure called glucosazone will be formed, which is yellow in color. So, if our phenylhydrazine is in excess, then a structure known as glucosazone will be formed, which is having a yellow color. Along with it, what will be formed? Water. We have already taken out, but let's remove this one. Water along with C6H5NH2 plus NH3 will be formed in the product side. So, if glucose reacts with phenylhydrazine in excess, then a yellow color glucosazone compound will be formed. So, this is when it is in excess. So, this will be the condition if our glucose phenylhydrazine is present in excess. So, these are all the evidences of the glucose. Let's recall them once again. So, if we once again draw the structure of glucose and recall all the evidences, it will help us. So, once again drawing the structure of glucose, CHO, let's draw it completely. This is our structure. So, let's recall all of the evidences for the structure of glucose. First of all, we saw the preparation of glucose, that was from sucrose. Whenever sucrose undergoes hydrolysis, it gives glucose as well as fructose. Now, there are total 6 evidences for the structure of glucose. So, first evidence was reaction with hydrogen iodide in the presence of red phosphorus accompanied by prolonged heating, which showed us that the structure of glucose contains 6 carbon atom. It is a straight chain. That is 1, 2, 3, 4, 5, 6. There is 6 carbon atom. It's a straight chain. Then we have again the second evidence which proved that is reaction with hydroxylamine or with cyanohydrin, which showed us that there is a presence of a carbonyl compound, but it was not yet specified whether an aldehyde group is present or a ketonic group is present. Then after that we reacted it with a mild oxidizing agent, bromine water. When gluconic acid was formed, then it was also proved, yes, there is a presence of an aldehyde group at the first carbon atom of the structure of glucose. Then after that, we reacted with a strong oxidizing agent, that is our concentrated nitric acid. Then we came to a conclusion that yes, the structure of glucose kinase is a primary alcoholic group at the 6th position. Then after that, we had a reaction with the sour pentacetate formation was there. When we reacted it with acid and hydride, pentacetate was formed, which showed that there is presence of 5 alcoholic groups, but yet it was not specified whether primary alcoholic group is present or secondary alcoholic group is present. After that, we reacted with phenylhydrazine. In that, we proved it that we got an evidence that there is a presence of 1 primary alcoholic group and 4 secondary alcoholic groups. Then there was one more condition, that if our phenylhydrazine is in excess, then another compound glucosazone will be formed, which is yellow in color. So this was all for today, our evidences for the structure of glucose. I hope you liked it. Thank you.